Hello. In this video, we are going to recast the van der Waals equation of state as the virial equation to third order and then determine the virial equation constants B and C in terms of the van der Waals constants A and B. Recall the van der Waals equation of state that the pressure is equal to RT divided by the molar volume minus constant B minus A divided by the molar volume squared. So the relevant constants in the van der Waals equation are little a and little b. On the other hand, in the Virial equation, we have RT divided by the molar volume times a power series expansion. So we have 1 plus constant big B divided by the molar volume plus the constant C divided by the molar volume squared. And just to keep in mind, B is a function of the temperature, and big C is a function of the temperature as well. Now we set two expressions for the pressure equal to each other. So, RT divided by the molar volume minus little b minus little a divided by the molar volume squared, and this is equal to RT divided by the molar volume times 1 plus B divided by the molar volume plus C divided by the molar volume squared. We can expand the right-hand side as RT divided by the molar volume plus big B RT divided by the molar volume squared plus big C RT divided by the molar volume cubed. Now we multiply each side of our equation by the molar volume cubed, so that we get RT times the molar volume plus big C times RT. Next, we multiply each side of the equation by the quantity, the molar volume minus B. As a result, we get T times the molar volume cubed minus A times the molar volume minus the constant B equals RT, the molar volume squared, times the molar volume minus B, plus B RT, molar volume times the molar volume minus B, and then lastly we have CRT times the molar volume minus B. Next, we use the distributive law to multiply out these particular expressions, which gives us RT times the molar volume cubed minus A times the molar volume squared plus little a, little b times the molar volume, and this is equal to the right-hand side, RT times the molar volume cubed minus little b, RT times the molar volume squared, plus we have big B times RT and the molar volume squared minus little b, big B, RT times the molar volume plus CRT times the molar volume minus little b c RT. We can subtract RT times the molar volume cubed from each side. This term drops out, and then this term drops out. And then our goal is to look at the powers of the molar volume. So we want to look at the coefficients for the molar volume on the left-hand side and compare them to the coefficients of the molar volume squared on the right-hand side. So make a little note here that this is the expression that concerns the molar volume squared. And we see that on the left-hand side, the molar volume squared has a coefficient of minus a. And then on the right-hand side, the molar volume squared has a coefficient of minus little b RT and plus big B RT. And so those are the coefficients for the molar volume squared. For the molar volume to the first power, linear terms, we see that on the left-hand side, the coefficient of the molar volume is AB. And then on the right-hand side, we see that the coefficient of the molar volume, so we have minus little b, big B, and then we have CRT. So the right-hand side is minus little b, big B, RT, plus big C, RT. So what we've done there, just to explain, is we've looked at the coefficients of relevant powers of the molar volume. So since both sides are equal, for any values of E sub m, their coefficients have to be equal. So we've just equated the coefficients on the left-hand side and the right-hand side for the equivalent powers of the molar volume. Next, we take our equation for the coefficient of the powers of quadratic powers of the molar volume. So we have our minus a equals minus little b RT plus big B RT. And we see that we can factor RT out of the right-hand side. So we have minus a equals RT minus b plus big B. Next, we can divide each side by RT, and that we get that minus a over RT is equal to minus little b plus big B. Adding little b to each side, we get that the virial coefficient big B is equal to the van der Waals constant little b minus a divided by RT. So now we have an expression for the second virial coefficient, big B. Next, we would like to solve the equation for the linear powers of the molar volume. So we have that little a times little b is equal to minus little b, big B, RT plus big C, RT. We can use the substitution that big B is equal to little b minus a divided by RT. So we have that little a times little b is equal to, and then we have little b minus a divided by RT. RT plus C RT. Now simplifying, we get that AB is equal to minus B squared times RT plus little a times little b plus big C times RT. And almost immediately we notice that we have a factor of AB on each side, which we can subtract. And this gives us that v squared times RT is equal to big C RT. We divide each side by RT. We know that T is never 0 by the third law of thermodynamics. So we can divide through, and we get the result that big C is equal to little b squared. So in summary, we've shown how we can recast the van der Waals equation of state in terms of the Virial equation of state to third order. I thank you very much for your attention. Have a good one.